As part of this fifth video, that is Spark Dataframe, so which is part of the playlist that we are bringing up. So that is a Databricks Certified Associate Developer Spark. So this course is helping you to kind of understand what are the different topics that you have to understand and practice so that you can attempt for the Databricks Certified Associate Developer certification. And also, if you are not planning for certification, it is definitely if you are just looking for the knowledge or the understanding of this Spark details in Databricks, so this playlist will be helpful. And specifically, this video, that is a Spark data frame, we will try to understand how exactly the Spark data frame is built, and we can basically understand with a simple code, execution of a simple code by creating a Spark session, and also we will understand how the internal architectural uh, overview of that particular operation looks like. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So quick check here, the important quick checks are like make sure you are using a headphone for the best experience. Also adjust the volume and the speed of the video so that if the video is too slow for you, you can increase the speed. If your videos looks very fast for you, you can decrease the speed and adjust it accordingly. Pause and take notes wherever it is needed. It is important so that you keep track of what you are learning, and recommended to watch full video and follow the course as per the sequence in this particular playlist, and practice as you go through the course. Any questions, suggestion, please comment them in the comment section. If you need any practice notebooks that we are working in this particular Databricks course, if you need any resources or data resource or any notebook resource, please comment your name in the comment section and also send a request, mail request to the this particular mail ID that we have mentioned. Okay, so without any delay, let's get started. So what exactly the we can expect from this video content is reading a file using a Spark session, right? And so Spark session will be created, and how do you read a file, and parallelly how do you create a data frame or write the content of the file to a data frame, and how you can display that data frame, and also we will understand behind the scene how this actually creation of the Spark session and the creation of the data frame looks like from the architectural perspective from the Spark. So now let's quickly jump to the Databricks UI. That as you can see the Databricks UI here. So you can observe there are a couple of options, and where you see workspace, and when you click on workspace, so in the previous video we have explained how to get all these notebooks, and also it is important to download the required data. So these notebooks are using some required data, so like some files. So we will see how to import that data. Okay, so you need to click the data. So whenever you want to import any files as a data, right, so you need to click on the data, and so it depends on the UI. So if you are using a new UI or the old UI, so it depends. So but there will be option of like to upload a file, or if there is no option of upload file, so just click on create table. So it will take you to this location, and as you can see, you are now into the Databricks file system. So the file store slash file store and slash tables is a root folder, and here you need to drag and drop all the folders that you will be seeing. Okay, all the files in a particular folder. So as you can see, so these are the files I'm using in this course. So I'm trying to drag and drop these files here. So if you need this particular files for your practice purpose, please comment in the comment section, and also uh, send a mail request, so that mail request to our email ID, so that we can send you the required resources. So, as you can see the checkboxes here, and you can see the file uploaded. Of all the 4 files are uploaded into a dbfs file storage. Once the upload is complete, you can just click on the workspace and just try to create a new notebook and name it as a with any name, right? And then as you can so just to verify, right, so you have uploaded the files into the Databricks file system, and just to verify if the upload is successful, you can execute this command. That is, this is a magic command, percentage fs ls, and you can give the dbfs files system in the single quotes, and you can see the 4 files are currently in the Databricks file system. So with that, we are now ready with the data, and also we are ready with the notebooks. So all other notebooks, as you can see. So in the previous video, we have seen how we are able to, import this notebooks, right? And if you want this notebook to be sent to you, so please comment in the comment section, and also please feel free to mail to our email ID with the request, and we will be able to send to you. So now that we are able to kind of create a all this import all the data that is required. So now let us see how the Spark session will work, right? So we will name this as a data frame practice, because so we will be seeing the basics of the data frame here. So now as you can see, like before we actually jump, so we'll just execute Spark. So Spark is just a command, right? And it executes something. So that means this is actually a session. Spark session, as you can see, there is a Spark dot session and Spark dot context, whatever you can do. But so the Spark is a in the hierarchy, the Spark comes first. And once a Spark session is initiated, so now comes you can do whatever, like you want to read the data, you want to read the data in a stream or whatever, right? So now we can try to execute this and see this comes it actually shows it is part of which class in the inner implementation. It is part of PySpark.SQL.read writer. It's actually a reader and writer class, and it is a data frame reader. So that means you are able to read this and write into a data frame. So now let us try to read the data, actual data, right? And if you just put a dot, and you can see a lot of options, and we are going to use the format here. So you can use many other options like as you can see ORC, Parquet, and all those options. But we want to explicitly specify the format here with the JSON as a file format. And so we need to also specify. So this is first part, right? So you know why we are using Spark. So Spark is a session, and why we are using reader, because if you want to read a data as a data frame, so you need to use dot read, and format is what you specify the file name, input file name that you want to specify, and then so you want to load the data. So in the load, you will specify what exactly the data you want to read. Suppose I want to use this customer.json, so I can copy from here to here and then try to read this. And if I just read this, it will just execute, but I want to write it to a data frame. So it will just execute here. So as you can see, it will not throw any error, it will execute. However, I want to write it to a data frame, right? So if I want to write, so as you just see here, right, it just displaying the data frame and its data types. So the very important point here is to notice it ideally, by default, so it has explicitly the parsed the data types. So I have not specified any data types, but by just seeing the data, it was able to uh, infer that particular data types. Okay. So now if I want to write it to a Spark data frame, right? So I'll make it as custdf equals to. So custdf will be my data frame, and I'm writing that data into a data frame. And as you can see, once the data is ready to data frame, it actually shows. So since it is a nested JSON, so demographics is again a struct data type. It is a struct data type, and so inside that there are again nested data types or nested data, as you can see here, right? So now let us try to display the data frame that we have read so that we can see the data that's been read into this data frame. The display command is executed here. So inside the display, we are giving the data frame which we have read, and once the display command executes, so you can see the Spark job as is able to display this, read this data frame and display what is there in the data frame. Basically, display is a command which can be helpful to display the data frame in a particular tabular format, so it is more readable. So you can print the data frame, but it is not so readable. So any data frame, if you want to see as a tabular data, so it is better to use a display command. And you can see whatever you are seeing, whatever you saw as a attributes or the columns, you are able to see here. And demography is a struct data type, and you can see it is organized in a structure. I mean, in a particular structure because it is a nested data, right? So this is how the data is read from a JSON file from the DBFS, and we are writing into data frame. So and that data frame is being displayed here. So what is happening here internally is here the Spark session is getting created, and we are reading the file and then writing it a data frame. And data frame is actually this entire end-to-end operation actually is maintained by cluster manager, and cluster manager will segregate the task to the event like executors, and then executors will actually process the data in the nodes, actually in the different nodes, because we are talking about distributed computing here. So we will see that how exactly architecturally this particular process looks like. So what happens when you executed that command, that is data Spark.read, right? And you give the format of JSON, and we have read the particular JSON file and written into a data frame. So the same operation when you talk about here architecturally, if you really see, right, so the request that you are making, that will exactly come to the cluster manager out here, right? And once the cluster manager receive the request, so it will ideally, so as you can see, we are talking about a distributed computing, so we have multiple nodes here. So this is node 1, this is node 2, node 3, node 4. We have a 4 node cluster here. But the Databricks that you are practicing, which is a community edition, which has only one cluster, it's a single node cluster, because it is just for the practice purpose. So Databricks has given only a single node cluster. But ideally, you can create a number of nodes, that is a number of worker nodes as per your requirement. So what happens is this cluster receives the request, and the cluster manager, so it actually sends out a request to a node manager. And from the node manager, what happens is the Spark session is executed, because you're doing Spark.read. So once the Spark.read exactly happens, so each executor starts reading and you write it to a data frame. So each executor starts processing, in this case, parallelly. So once this request is, the first step is the Spark session is created. Once the Spark session is created, so the executor start processing, and then so parallelly, so as you can see, there is a different nodes, and the data frame is read as a parallelly. Suppose there is a 3 GB of data, right? And this 3 GB of data, which is supposed to be read as a data frame, will be equally distributed among the executor processes, and then it will be read, and it will be basically why we so this each executors will hold the in memory of the data that it wants to read. It is a in memory. It is actually having a in memory processing here. That means it actually temporarily loads the data into the RAM, basically into its primary memory, and start processing it, whether it's a read, write, or any transformation, any operation. So it is dependent on that. So this architecture we have already seen in the previous videos in very detail. So I don't want to go in depth again. So if you want to know this architecture in detail, I would recommend you to please go and check the videos in the same playlist. So ideally, yeah, the Spark session is created and then job logic executes and then tasks get created. The tasks are a very low level. This is where the execution starts basically. So it's very low level. It is actually a part of a task. A set of tasks will constitute to a job. So it's something similar to that, right? And now let's move to the next one. So what exactly happens? Executor process hold data in memory. So that we're talking about in memory, which is very important. So basically, if you consider a cluster, right? So cluster will having a, say example, it has a executor cores, which is 4. That is your primary memory, and you have a secondary memory where it constitutes of 10 gigs of executor memory, which is actually meant for storing the data. And then, so when you do a Spark.read, so what we did is we did a Spark.read. So you can do a Spark.read and you can read data from any of the sources, right? So you can read structured, unstructured, semi-structured data, and you can read the data from any of this file, any of these sources, maybe Azure Blob Storage, Hadoop file system, and the data lake, Apache HBase, Cosmos DB, MongoDB, Google Cloud Storage, and even Databricks file system, which is a native file system, and Amazon S3 and Cassandra, and also like real-time sources like Apache Kafka and Event Hub, and also like databases like SQL, Postgres, etc. So once the data is read, what happens? So once the data is read, the data frame is created. So but actually in the physically, so the data is not stored in one location. It's actually partitioned into multiple chunks and it is stored physically in a different location. So here what we're calling partition is actually a physical chunks of the data that being divided into multiple partitions or multiple chunks and physically stored in a different nodes. So why we are storing in physically in different nodes? Because to perform a distributed computing. Because so distributed computing cannot happen without the data stored in a distributed manner. So if the data is stored in a distributed manner, so then only you can perform a distributed computing. Simple as that, right? So once as you can see, when you're querying the data, when you're reading or writing the data frame, it is the Spark encapsulates into a data frame and for the user, so you will get the result from here. But actually, physically, what happens is the Spark cluster manager will go and whenever you want to read the data, it actually gets the data from all of these partitions. And so this node managers will be there, and node managers will go and get all the data, and then it gives back to the cluster manager, and cluster manager gives that data back to the user. So this actually happens in the behind the scenes. And like the advantage of doing this is suppose the data which is being stored in first partition, second partition can be processed in the using the first node, right? And the data is which is stored in the third and fourth partition might be processed by the another different node. So basically the parallel processing, the processing in the sense it might be a reading a data, writing a data, or it might be any kind of transformations. So everything is considered as the computing here, and everything can happen in a distributed manner. So hope this is clear. So if any questions, please comment in the comment section. I'll try to answer or clear the doubts here. So now let's move to the next slide where we will discuss about the data frame. So data frame is a Spark concept where it's a combination of rows and columns, right? So it consists of rows and columns here, and each row will have a fixed set of columns. That means it is not like first row is having 10 columns and second row is having 11 columns, right? Each and every row has a fixed set of columns, number of columns. And it is very similar, this concept, I mean, this is very similar to the database tables. So where database tables has rows and columns, and it is having a tabular structure in the database systems. So this is a simple data frame, but the concept of data frame here is why the data frame is necessary is so the data which the data which you want to process, basically it will be in your source system, right? So the file, there will be a files in your source systems, and each files has to be, each, it might be in a file format or a tabular form, I mean in a database tables, but end of the day it will be in a source system. And to perform any compute, so the data has to be brought to the Databricks cluster or the Spark cluster here, right? So this is a Spark cluster, and once the data is brought to the Spark cluster, so actually it is loaded into cluster memory. So once it is loaded into the cluster memory, that means it is in the Spark session, it is in the cluster memory of the particular data that you are processing. It will be in the cluster memory, and in that particular session you can use this data frame, particular data frame, for any kind of transformation. So without bringing this data into the cluster, it is not possible to process. So that's the reason you bring the data into the Spark cluster. So that is via the data frame. So the data frame is helping you to uh, encapsulate that data and bring it to the cluster level, or in the cluster memory physically. And then once it is there, you can perform any kind of operations, any kind of transformation on top of this data frame. So that's the whole advantage or whole uh, usage of a data frame. And quickly, what is data schema? Data frame schema, actually. So this is data frame schema, right? So data frame schema is nothing but where it actually define a column along name along with the data type for each column. Data is not it is the columns and associated data types. So you can see in two different ways. As you can see, when you do a Spark.read format and the load, you load the data into a data frame. So in the output you can see the schema which is inferred, and address ID it as read, it is long, this is it is a read string. So as you can see, few are array, few are string, few are struct, right? And the another way is data frame dot print schema, and this also will start with root, and it will give the hierarchical the structure. So if it is nested, so basically here it is a demographic is a nested, we are using a nested JSON, so that is why there is a nested data type which is created, which is a struct data type, right? So this, as you can see, we have not defined any data type for each columns, right? But Spark is intelligent enough to kind of infer that particular data type, and it actually assigns its own data type. But it might be dangerous, because when you're performing some calculations, this might not help what the Spark is assuming here or inferring here, the data type. It might actually create a confusions when you are doing a transformation. So it is there is a solution to that. So that we will see in the upcoming video. But so this is how you see the data frame schema. So quickly about so so data frame, we know that data frame does a distributed computing, but how exactly it happens is so suppose you have a data frame here, and you do a filter, right? And you want to traverse the entire data set that you have read, and you want to find whichever the records which is having first name that is starts with S. So what happens is basically, since the data is distributed into multiple nodes, so say for example, this is node 1, this is node 2, this is node 3, and this is node 4. So data will be distributed across the different nodes, right? Or the different workers here, right? And so this is a data frame. So when you read a cust.df is a data frame, So as a user, you will be interacting with only with this. But physically, what happens is once this request is made, so the first name will be like S will be searched in the node one, right? And all of these partitions, and then parallelly it will be checked in all of these partitions. Parallelly, it will check in these partitions similarly like this. So all this process searching will happen in parallel. So if there are like 10,000 rows, so and you have 5,000 rows here, right? And similarly 5,000 here and 5,000 here, 5,000 here. So parallelly everything is searched, and each the result will be accumulated here by the cluster manager, and this result will be returned to the user. And that the output will be whoever is having the first name like S, so that output will be result received here and displayed to the user. So the power here is instead of taking like 20 seconds, so since it is a parallel processing, it might just take 5 seconds to search this. And so that's how data frame actually is distributed